Another edition of 3D Printing News Unpeeled, thanks to 3dprint.com. And today, well, we're going to talk to you about Relativity Space. So Relativity, the company that has raised 1.3 billion, I think, or over 1.3 billion, and uses that to 3D print not some parts of its rockets, but almost 85% or more of the rocket, including the main structure, and has developed its own large-scale 3D printing technology to do so, had a really well-publicized, well-followed launch the other day. After two abortive attempts, the third one did launch, but the second stage failed to ignite, meaning that overall the mission was a failure. Now, this is a blow to the prestige of 3D printing because it was touted as a success for 3D printing, which would have been good for us, but now it's a failure for 3D printing. And we should realize that if people are harnessing our technology and using it broadly and they fail publicly as Relativity is done, well, then that also affects us very, very negatively. Now, on the upside, space is very hard. The tolerances are very tight. It's very difficult to do what they're doing. And they've got $1.3 billion. So they've got a lot of time and a lot of money, hopefully still left to correct these errors and to go forward. Theoretically, they could print a new rocket in about 2 months or so. And of course, the idea of making more of the rocket plastic, if you will, making more of the rocket 3D printable could mean they innovate faster, they go to market faster, and it's cheaper for them to iterate and get new designs in. So this, it could be quite doable for them to quite quickly iron out the error and do it, and do it correctly the next time. So it could be a huge validation for the technology in the long run. Now, what we must realize, however, is that lately Silicon Valley has really favored 3D printing and other startups that are very vertically integrated. So rather than just saying we're going to do the machine, I'm going to sell a machine, they prefer to have a service, right? And rather than just having a service that does a 3D print service, for example, well, you make the machine and the 3D print service and the technology and the material. Super vertically integrated, you capture more of the market, you have a really, really clear defined, you own the customer, you're really clear defined go-to-market, clear defined area to play. And investors love that stuff. Recurring revenue, a lot of control, a lot of market power. They love it. But we need to think, wait a minute, the question of Relativity Space, have they bitten off more than they can chew? Have they, by designing a really complicated 3D printer and also a rocket, are they either A, doing something that no one else can do, which will mean they ultimately would be more successful, or B, have they just bitten off too much organizational complexity? And is it just too complex a challenge for them to do? And that's kind of the things we will need to see. If we look at humanity generally, there have been space programs, and there have been things like the Manhattan Project. They're ridiculously complicated projects. Not only like the Manhattan Project, for example, you're not only making a bomb, but you're also making the fuel. You're also making all sorts of new materials, all sorts of procedures, and all sorts of energy kind of solutions and stuff like that. So the technical challenge is formidable. And we have yet to see if it makes more sense to what every other space company is doing. All the other new space companies are just buying printers and using them for propulsion units and some key tip of the spear type units. Or maybe ultimately it would be better to build your own machine and then go forward that way. So I think it's something to think about. Is it maybe too complex, and is it maybe two different companies, right? And should they maybe split up this kind of making the machine and making the rocket type of startup, or should they maybe organize this in a different way? Or indeed, is this just, it's space, it's complicated, stuff goes wrong all the time, and this is just the first launch, and we'll long forget this with subsequent Relativity successes. We don't know, but I think it's something to think about. The next piece of information comes to us, from the NIST, actually. The NIST put it on its website, but it is a work by Hans Hendrik Koning and Niklas Höllender Pettersson, who are, as you may have guessed, Swedish, and they're from the KTH Royal Institute of Technology in Sweden. And they have worked together with NIST researchers and a bunch of other people from all over, and two different synchrotrons, right? Two different particle accelerators. One of the Argonne National Lab one, the Advanced Proton Source, and the Paul Scherrer Institute's Swiss Light Source is used as well. So both these particle accelerators were used for to study the structural behavior of metals, specifically the cooling behavior and the structures of metals using or after essentially or during additive manufacturing. So what we get then is we get these different. We can see in the picture we get these Austin type and delta ferrite structures. And the idea is they look at this in such a way as to, well, the goal is to have better control over the structure. And if we have better control over structure, if we know what's going to happen, we have a higher yield, we have better properties in the end part, we really know what we're doing, and we can maybe even qualify things, parts, machines, materials much faster in the future. Now, what they found is there's this thing called the Kurz-Giovanola-Trivedi model, KGT model, which is a solidification model, and they've managed to get their data to confirm to this model, which would, on the whole, mean that we've made metal 3D printing or laser powder bed fusion with metals a little bit more predictable. And it's a wonderful step, and we don't always, kind of take stock of this kind of really necessary work being carried on and these kind of things. We are too much of a black box, and this is making us a little bit less of a black box. This is making this melt pool a little bit less mysterious, and I think this is wonderful to see. The next news is from 3D Systems, and it's with connectors. Now, connectors are one of my favorite 3D printing applications. We've got a lot of high mix, low volume. We get a lot of really specific criticality. So we have some connectors that are really critical. Think of MRI machines or military hardware, things like this, aviation things. So really high value, really critical. There's often a lot of money tied up in stock. And sometimes the stock needs, the availability of stock in different countries and regions means that there's the outlay in molds and tooling and things, and the outlay in stock is quite considerable. So the capital tied up in molds and stock is a lot comparatively a lot in connectors compared to the unit price. We know we can make connectors. There's people making connectors for all sorts of things with 3D printing, but we haven't seen a lot of movement there. We haven't seen a lot of startups focus on this. We haven't seen, or to my knowledge, not even one startup focus on this, although some companies are doing some projects with it. And so I really love this thing, which 3D Systems worked together with TE Connectivity. And this is a brilliant thing. And I love this. And I think that 3D Systems and also other OEMs should be doing a lot more of this. What they've been doing is they made a specific resin for connectors, right? For their Figure 4 systems, right? Then they did UL compliance kind of stuff about thermal aging, UL 94V0, and they got all the relevant certifications done, which is quite tedious to do on these kind of things, especially with connectors where they really want this stuff to hold up over time. And now they're releasing this as a solution together with this TE Connectivity. So it's what they think is their thing is small volume production. They think that it'll increase their time to market and allow them to produce some specific geometries that they can't normally do. They're targeting, which I think is quite interesting to find out, cellular kind of cell tower, cellular kind of applications, appliances, which would be quite interesting, and data centers. So this is wonderful. And I love this connectors as an application, first off. Secondly, what I also adore about this is the fact that, I think that rather than sell a machine, which will take you many months, and then it will take them a year or so or 2 years to get to grips with it, depending on what they're making and what machine it is, you can just say, hey, look, order connectors here, or we will make an end-to-end value proposition together with you that is really perfect for the connectors, the software, the printer, the material, everything. And I think this is the way forward. And this will really accelerate the adoption of the industry. So I think this is really good news, and I think all the other OEMs should do this as well. Anyway, thank you so much for your time today. My name is Joris Peels, and I hope you found this valuable. Keep the feedback coming and your ideas, and thank you so much. Have a great